All right. So thank you everybody for coming. This is our last, yeah, our last business analyst experience workshop of the semester, from spring 2021. We have here Dr. Tala, and she's gonna explain more about Rapid Miner and the powerful tool for machine learning and other analytical skills. Thank you, Professor, for coming here.
Awesome. Thank you for having me here. I see Kevin is here. Kevin, do you want to teach? He's
Yeah,
he already knows all the stuff that I want to talk about. It was in my class. So I don't know about the other people. Juan, I don't know if I pronounced Jamari's name correctly, and Pablo. Pablo was in my class as well, but I don't know. So is it new to you, or you have some experiences with Rapid Miner?
For you, Juan, or anybody.
Can you hear me or no?
I can hear you now.
Yeah. No, it's my first time using it.
Okay.
It's an introduction class for me.
Okay, and I'm assuming Eduardo, you had it before.
This is my second workshop and my first hands-on experience. Yeah, my first hands-on experience.
Okay. All right. So let's just basically jump into the Rapid Miner and how it works. So Rapid Miner is, as I said, the student version comes for free. The commercial version with more than 10,000 rows of data, and that's something the companies want, requires purchasing. Now, this is mainly used for data mining and machine learning type of analysis. Like if a company wants to concentrate only on visualization, then probably Tableau would be a better tool to use. And another thing about another characteristic of Rapid Miner is that it is a very user-friendly GUI interface it has, right? It does not require any coding, and unless like this R or Python or other programming languages that are out there requires you to actually hard code. Of course, there are libraries that you use the libraries to do the type of analysis you want to do. But here, everything is just a drag and drop, right? So in that sense, it is very easy to use. Now, the challenge would be everyone who sits in front of a Rapid Miner software can just drag and drop some processes and create something. And the big challenge would be, how do we interpret it? Like, what does it mean? Right? The process, okay, you brought in some data, you tried to do some analysis on it, you derived some tables or charts. Now, what does that mean, right? Or is it really meaningful, or is it really answering the type of question you wanted to answer using that data? So those things becomes important things. Why I'm saying this? Because yes, you need to get familiar with the environment of the tool and how it works, like the workarounds. But it also requires a background knowledge of different techniques of, say, machine learning, or say data mining, or different type of statistical methodology that you need to know that, okay, I need to apply this methodology to drive to that conclusion, or to be able to answer that question, right? So it requires some conceptual background before you can start modeling. I'm going to share my screen with you now to just look at this together. So if you have downloaded RapidMiner on your computers, the first thing you have to do is to create an account. And if you create your account using your FIU email address, then RapidMiner usually grants you the free version. And you can have more than 10,000 rows of data to work with. This after you do that and you create your account, then you come to this window where this is the main place that you work in the RapidMiner environment. There are several windows. You got the repository window on the left, upper left side. You have all the operators on the lower left. You have the big process window in the middle. And then on the right side, you have parameters on top and hop at the bottom. Now we go through each one of these one and see what those are, what those means, like what we can do with this. Now, under the repository window, that's where you bring your data to RapidMiner. Okay, if you want to bring in any new data, that's where you put it. You also save all your processes here. So now I have a lot more stuff, so if I close that, this is probably what you see. RapidMiner provides some resources itself, and those are actually very good resources for learning. So if you look at the templates, the samples, those are a very good place to study. So if I say, for example, in the repository, I click on the samples, you see that it gives me some samples for the data, it gives me some samples for processes, and then some templates. And also a different folder for, entirely different folder for time series analysis. That's actually new. New as in like just this year, I think last year they added. Then there are tutorials, and the tutorials also is a very good place. If you just open one of those, then and you see that there are less nested folders. So when you click on them, then it opens, and then you have multiple things to work with. And now I just double click on the process for the very first one. And you see that there are dashed lines here. Basically just give you hints step by step and telling you what to do, right? So it says, okay, retrieve Titanic training. That means that look for the Titanic training data and then bring it here, right? And then link it. So now under here, you also have a folder, the data folder. If you click on that, then you see that there are a lot of data sets available. Yeah, and that's actually a very good point as well. RapidMiner is very resourceful in that sense. So they have their newspapers, they have their videos, they have tutorials. So if you just create your account, then you'll be able to enroll in any of these things, and all of them are for free, and just learn from there. Now, okay, the data. Some of these, so these data sets are just there for you to look at. And if you say, for example, double click on one of them, let's say double click on deals. I'll come back to the Titanic training. You just see the data set itself loaded, right? Now, in this data set that you're looking at right now, there is a column for just the rows, and then you have future customers of certain, maybe a seller, maybe a financial institute, maybe a company. And the future customer is just includes yes or no's. And then you have age, you have their gender, and then you have what was their payment method. So say, for example, if this person is a male who is 64 years old, who use a credit card for payment, and that person is probably loyal to the company, probably enrolled in the loyalty program, so on. So that's why it says future customer. So now, if I click on statistics on this data, so the first tab was data, the next one is statistics. If you click on that, it gives you a snapshot into that data, kind of explaining what's going on here. It tells you what is the type of the data. So right now you just saw future customer only included yes and no's. So RapidMiner identified that as binomial type data. Means that it can only hold two values, either yes or no. And then it also tells you, up here it says missing, it means that there are 0 missing values. There are no missing values in that column. And then RapidMiner decides for if we want to do, say, for example, a classification model, then to evaluate the classification model, and it is a binomial, so you got to think about what do I consider as a positive, what do I consider as a negative, and RapidMiner just assigns one of the classes to negative, one of the classes to positive. That's fine. And then it gives you how many, because it was a categorical type data, you only had yes and no's. So it tells you how many of no's you have and how many of yeses. You got 527 no's in that column. You got 473 yeses. Now, if I click on this, it also shows me a bar chart of the data. And I can click on that and go into, and so basically you're opening the visualization, go into the visualization tab, see it bigger, and then you can make changes on it. If you don't want to see it as a bar chart, then you can click on it. And now you can decide, let's say I want to see it as a pie chart. So then it generates a pie chart for you for those portion of no's are denoted by the blue color and a portion of yeses. So you see that it's very fast in generating some of the basic statistics and very fast and helpful in generating some charts. If I click on details here, it also gives me a table that nicely shows how many yeses, how many no's, and also gives me the percentages, or basically the ratio of yeses, the ratio of no's. Now that's when you have a categorical type data. Now for the age, which is an integer type data, right? For this one, again, RapidMiner guesses what is the type of the data is. Here again, no missing value. This data is clean, so there are no missing values. Now for this one, because it is an integer, you are interested to know, okay, what is the minimum? What is the maximum? What's the range of this data? And what is the average? So those are immediately there for you to look at. And then if you click on it, it also gives you the standard deviation. So that's also another important statistic that you want to look at when you deal with this type of data. And it also gives you the histogram. Now, again, if you click on this one, the visualization, you can see it in a bigger version. And you know, like with the histograms, you decide on the number. If you have done this in Excel, say, for example, you decide on the number of bins, right? Then you calculate the bin ranges. Then you put that into the histogram tool in Excel to generate it for you. Here, one click. You don't even have to click, it's there. Now, if I say, you know what, 10 bins are too many, I just want to look at 5, then you just change that to 5 and it regenerates the plot for you with 5 bins.
I have a question, Professor.
Yeah.
for reporting, I really I'm thinking this now at the moment that I want to share this file or share these insights to a decision maker. Does the presentation, do you present it in the same RapidMiner you know how do you call it, the same
environment. Yeah.
GUI environment, or do you can transfer it to a PDF or any other
No, you can
and
bring it to your, export it to, say, for example, your PDF file, export your chart as a PDF,
okay.
or export it as a PNG or JPEG and put it into your Word document or PowerPoint slides, what have you, like however you want to present it. If you're making a report, you probably want to put it in a Word document and make it a PDF if you want. Same thing, like for PowerPoints, you can do that. So yeah.
But you won't get, yeah, exactly, you at the end you won't get the interactive, the interaction that you're having now with
So
the
if you
graphs.
do this, you just have the image. It's not
Exactly, yeah,
gonna be, yeah,
exactly.
it's not gonna be interactive.
Hmm.
But if you want to have the interactive version, like change something here and then immediately see it, then you just have to do it in the
In the
RapidMiner
RapidMiner
environment.
environment. Okay, perfect.
Okay, so coming back to the statistics. As you see, the same goes for the gender, but then for the, so gender is very much similar to the future customer in terms of the type of data, and because there are only two values, male, female here. And then for the payment, you see that it considered as a polynomial type data, means that you have more than two categories, categorical, but you have more than two classes there. So then it gives you the least, what was the one that was the less frequently occurred in your data, and the most. So you got check, there were only 68 of them. 68 people choose to pay with check. And the most frequent one is the credit card. 652 people decided to pay with the credit card. But we also have another option here of cash. Now, if I click on the more here, and if I click on the details, then you have the full table that includes everything that you have in that data. So like, for example, there you have it for cash, and then a fraction of each of them, the relative frequency. And then of course, here's what, if we had any missing value, it would be denoted here. And then you can also look at the visualization and change it to any other format if you want to look at it in a different format. All right, so that's just one data set that we were looking at. Now go back to the design. So I said you can use the tutorials, right? So this was just a data set that we just look at by just clicking on it. Another way to look at a data set is like the one that is asked you to do here in this tutorial, where it says retrieve Titanic training. Now, this big white window here is the place where you put all your processes, you create all your processes right here. So say, for example, if I want to retrieve Titanic training, the Titanic training is right here. Now, one easy way to just bring it into the environment is just drag and drop it. So you click on it, hold it, drag it, and drop it into this space. Now it goes and sits there. If it's just sits there, you cannot do anything with it. You have to link it from the output port, right? From the output port, click on it, a line appears, and then make sure you link that line to the results, all the way to the results, okay? RES for the results. Once you do that, it turns to purple, and now RapidMiner recognizes it. Okay, so one thing very important, in these processes, everything needs to be linked to each other to work, and it works in the order that you put the operators and the order that you link them. Okay, so now if I run this, then I would be able to see this data set. So to run a process, you make sure you link it, and then you click on the blue button, the blue play button on top. And now you can see what's going on in this data set. You got survived, you got age, you got the passenger class, what was the gender, what was, how many siblings or spouses they had, how many parents, and then how many parents on board, and then passenger fare, how much they paid. Now, same thing here. If I click on statistics, then immediately I have all those information that I wanted to see, and then I can visualize each of them. Now, so that was just one bringing in one of these operators. And now if you want, you can continue. So this was just a very simple one, but you can continue with these templates to now put a model on it, right? Now you see that this template asks us to do, okay, bring the Titanic training and put a decision tree on it, right? Now finding a decision tree is very easy. So we bring that Titanic training here again, right? And then in order to find an operator, you just search it under the operator window here. Now this operator window is basically what you do in your other programming. You have to hard code, you have to write, or your libraries. So you have to say, for example, if you're working in R, you have to bring and call a library, then only you can use it. Or same thing in Python. You have to bring in the packages and call those libraries. Here, you have them here listed, and all you need to do is just drag and drop them into the main window. And if you want to search for one, so you just write its name. Now, if I want to search for a decision tree operator, I just search for it and it's there, right? So I can just drag it and drop it into the main window. That's a decision tree. Now on its own, you see that there is an error here. Why? Because it is not linked. So RapidMiner doesn't know what to do with it. Now I have to link it from the output port of the data to the import of here, the training. Now this is linked. I also have to connect it from the model to the results, so that in the results it show me the model. Now, if I also want to see, say, the examples means that the rows of data that I have to link that one as well to the results for RapidMiner to show it to me, otherwise it doesn't. So basically what it means is that whatever you link to the results, that's what you see a tab for. Now, before we can run a decision tree, this data, as we were just looking at it, you see that one of these tabs, one of these attributes, survived, is highlighted in green. That's the way that RapidMiner tells you that this is, I understand this as your label, or as your target variable, as your dependent variable, as what is it that you want to classify or predict, or do something with it. If you're bringing your own data set, just show you how to do that in a little while, you have to tell RapidMiner which one of these attributes is my label. Otherwise, of course, it doesn't know. But because this data set was one of the samples of RapidMiner, so it's already embedded there, it knows that we want that to be the label. So it's already highlighted as green. So now RapidMiner knows basically what we want to do here using the decision tree model, which is one of the techniques that you use for classification, is based on all this data that we have. We know the age of the customer, passenger class, whether they were in the first class or second class or what, based on their gender, and in terms of, okay, how many people were there with them on board, whether they had a child or spouse with them, whether they have parents with them, and how much they paid for the ticket. We want to see if we can kind of create a model that tells us who will survive, right? Who will survive in a crash of the ship. So now going back to the design, everything is linked. If I play this, if I run this, then RapidMiner creates a tab, decision tree. If you click on it, it gives you a very huge model because we didn't really change anything on the decision tree. So it gives us a huge model. And on the top, I'm gonna make it a little bigger so it's more easier to look at. Actually, I need to move it, and you can move them. And this is not definitely a very good model because we just didn't do anything on it. We just ran it as it was. So I'm gonna make them a little bigger. Okay, so that we can see all of it. Now, there we go. Now, a decision tree, what it does, it puts the most, of course, there are the conceptual concepts that we don't want to go through all of them now here. We just want to see how RapidMiner works. So it puts the most important variable that kind of makes that decision easy and in terms of who will survive on top. Okay, so it says sex seems like plays the most important role. Now, if you are a female, you were a female, then it goes down this path, right? And then it tells you, okay, if you were a female and the next important variable becomes number of parents or children on board. If you had more than 4.5, basically means that more than 4, then you won't survive. If you had less, then the next important attribute becomes number of siblings or spouses on board. Again, if you have more than 4, you don't survive. Then the next important thing is the passenger fare. So basically means that if you were less than 4 parents or children, still a chance. If you're siblings or spouses less than 4, still a chance. Now it looks at the passenger fare. If you paid more than 35, is it pounds or dollars? I'm not sure. Then yes, then you have a higher chance to survive. See that the blue one stands, and if I hover my mouse over this, it tells you how many yeses and how many nos are there in that branch. So because majority of that is yes or yeses, then it highlighted as yes. If you pay less, then again it looks at your number of parents and children. So that becomes another important. And again, important factor. So you see that that's how you interpret the results. So each of these end nodes on the tree comprise of a set of rules that starts with some if statements. If female, then parents more than 4, then no. If female, parents less than 4, that's important, and also spouses more than 4, then no. Now these descriptions are listed on the second tab here, the description. So all those rules are now written here that we can use now for decision making, right? So that's kind of generates a set of rules for us. Now, this model, of course, is not the best model here because we didn't tweak anything about the decision tree. Decision tree has its own parameters that you can change and tweak to get to a better model. Probably you don't want to have such a huge tree with so many branches to make a decision on. It's better to make these models more simpler if we can get to the same accuracy of the model, we can get to the same predictions. So changing of these criteria, that requires a better understanding of what decision tree is, what are those parameters, if I change any of these parameters, what exactly that means. So I want to encourage you to go back and read, because there are so many operators here, and read about what each of these operators do. Now, where am I supposed to look for resources? One of the very good resources that you have is right on the page. So down here in help, you click on any of these operators. Down here in help, you have a big window that kind of describes, first of all, what a decision tree is, what it does, and then for each of the inputs that you can tweak and change, the information are here to show you what those means and what we can do with those things. So I really encourage everyone to, if you want to work on any of these operators, read the help section. It's right in front of you when you're working, and therefore you don't have to go search for it anywhere else. And make sure you're doing the right thing. So basically now we have all these windows covered. You have the repository window where your data and processes are saved. The operators have all the operators that RapidMiner offers here that you can choose and work on. The main process window where you have your process, you design view, and then when you run it, you go to the results view, right? So, and then you got parameters for each operator. You see that these parameters changes. So for the decision tree, it only shows you the parameters of the decision tree. If I click on the retrieve data, because retrieve data only needs a source file, like where am I going to read this data from, then that's the only thing that you have here on the parameters. So the parameters changes based on the operator that you're on. And then the help also shows the description and then the parameters explanation and all that for the operator that you're clicking on. So now if I click on retrieve, this also changes to retrieve. Now up here, beside the design, which is this process design window and results where you see the results of your analysis, there are some other tabs here. One is the turbo prep, and these are something that RapidMiner very just recent, like last year again, added the auto model and then the deployment. Now these are the kind of tools that are provided to kind of make it even more easier. So you can just now load your data here, and it will recommend the type of analysis that you want to do with it. Like you don't decide, it will recommend, and then it cleans it. If you want to generate new attributes, you would just say like, I want this attribute, it will generate it, and so on and so forth. And then the auto model again would do some modeling based on the data that you say, based on say like here's the label. Let's say I bring in the Titanic data and say the label is survive, not survive. And then it automatically creates some models. And then for the deployment, it kind of creates reports, right? Now, I am not a big fan of these 3 tabs. So I don't really recommend my students to use these tabs. And the reason is it kind of blinds you, because then you don't think anymore. Then you just want the software to tell you what to do. And that's not the best strategy. You want to think yourself and you decide which model I should use, what attributes I should use. So in the best case scenario, these can be like a guide or consultant kind of a like AI consultant tool for you, but I don't really recommend using them as your final model generating kind of thing, because well then it's completely ignores the human brain and it all goes as the computer decides for everything. So that's what I think about it. Because RapidMiner makes your modeling very easy. You just drag and dropping. And if you don't even think about the model that you want to bring in here and it does that, then what is our am I just a clicker here, or am I making the models myself? So but it's there, so that's one thing. Now another thing RapidMiner does is this. Down here you see the recommended operators. That's what they call the wisdom of the cloud. And that's kind of provides some statistics in front of them. That basically means that 44% of the people who used the decision tree, after that, they used an apply model operator, and some 43% used the set role operator, 33% used select attributes operator. So it's kind of, again, hinting you what needs to be done next, right? If you know what you're doing, then you probably do not need to look at that. But it's there anyway. Like if you feel like, okay, I'm stuck here, I don't know what to do, then maybe. Okay, so now in terms of the operators that you have available, some of them is just data access, means because when you use your data, you can link it to a database as well, a SQL server, and call your data from there. So data access, the operators here gives you that flexibility.
I have a question, Professor. So when you were saying something about the turbo prep and the auto model and all those things, it took me out of one of the things is that does RapidMiner can help clean data, or it shouldn't be used for that?
Oh yeah, definitely. So cleansing data, you have a lot of operators on here that helps you with the cleansing of the data.
Wow.
Yeah.
Wow.
And it's very easy to do. So you can do normalization, or merging, bringing data set from different sources, take care of the missing values, take care of duplicates, take care of outliers. If you want to do dimensionality reduction, means that you have too many attributes and you want to combine some of them and just have one, like group some of them into one and then use that. You can do that as well. If you want to see an example, I do have an example. So right now, so far, I was just talking about these samples that the software offers itself. But now, and most of these data that you see here are clean. But now let's say you want to bring in your own data. That's basically what we want to do. And then you work on that data. So for that, you just need to import your data. You click on this. And as I said, you can have your data on your computer, or you can link it to a database and just import your data directly from your database. Now, let's say if I want to bring it from my computer, then very simple. You just have to find where your data is. Let's say I have, I'm not sure what is the last, okay. Maybe I'll bring this one. That. And you see that it can read the data from the CSV files. That's like the easiest thing that you can format that you can bring. It can also read from Excel, so you've got options of Excel and CSV file. And you just click on the data that you want to bring in, you click on next, and then here you just specify anything in terms of the format. So if your data has header, then it has to recognize that that first row are only headers. And then where your data starts, and then if you are bringing from the CSV file, sometimes you have a semicolon as a separator, sometimes you have a colon as a separator, so you have to denote that. And then anything else here that, say, if you usually use a dot for denoting the decimals, or like the skip for this escape character. But then for any reason, if you had a different formatting, you can define it here. And then next step, RapidMiner guesses the data types. So say, for example, here I have a column called price, and then it guesses that's a polynomial data. Now, sometimes it guesses very well, sometimes it doesn't. So now for the price, because there are some missing values or NAs probably in the data, it just recognized that one as a polynomial. Now, if I know that it's not, then I can change the type. So I can change type to, let's say, this is real or this is integer because it is price. Okay. Now, the one that was just as empty NA, now it just considered that one as a missing value. Okay. Can also replace the errors with the missing values, so that can happen too. And then you have for this, we have screen sizes. Again, this one is recognized as polynomial. Now, if we forget to change it here, we can use these operators to change the type of data, so that's okay too. Like, you don't have to take care of all of these things right here, but that's possible. Okay, let's do some of these. And then another option it provides is the change of role. Now, if I know what exactly I want to do, then you can set the roles of all of your attributes right here before you even bring it into RapidMiner. Like, so now you bring everything correct. So if you know what is it that you want to predict. Let's say here I say I only use these data to predict the price of the laptops, right, based on the characteristics they have. Then I can change the role of price to what you have here on the drop-down menu, to label. And that way, RapidMiner recognizes that, you see that I highlighted in green, recognizes that, okay, from now on, this is the target variable. This is what we want to predict. Okay, this is the label. But as I said, it's not necessary to do it right here. You can do it in the processes later on. All right, so if there are any challenges, it does that. And then if there are any errors, it shows you. So right now I got 2 warnings for these. And then it showed me, okay, there are warnings for the NA in the price and the screen size. And I said replace errors with missing values. Okay, so those are missing. And then it tells you, okay, now where you want to put this data. So we usually put it on the local repository, and you can create this so you can put all your data in one place and then put all your processes under a separate folder so they don't mix up things. I actually have some mix-ups, but that's okay. So you click on data, and give it a name, and then finish. So now we brought that data into RapidMine. Okay. Now you can, all those things applies here as well. So now it knows that I got 2 missing values for price, right? 1 missing value for the real. And then there are other things. So because I didn't change the type for all of them, so although these were numbers, but now because I didn't change the type, it just considered NA as one of the classes, right? Which is not exactly what we wanted, but that's okay. We can clean it or change the type of data right here, which may be a little more time consuming. So if there are things that you know up front, it's best to do it there. And then if there are other challenges coming up as you work with your data, then you can take care of them in the process. As like kind of the best, what is the best practice. Okay, so now we got the data here. I'm gonna make it a clean slate. And now these laptops are here, and now I can bring that one into the process and then start working on that, right? Now, today we said we want to work with the Scholastic data set. I have it here already, so let me just bring that one. So this is a data set that we worked in the workshop before. This is from one of the AIS challenges. This is a very messy data, as you see, like there are a lot of missing values. In some of them, you may have duplicates, you may have outliers, so on and so forth. And now, one by one, you can start to kind of clean this. Now, if I want to do it one by one, it may be very time consuming. I do have the process from last time, so we can look at that. So if I want to bring in one of the processes from my processes, I can click on it. That will show me that. So now you see that this process window can get very crowded very fast, right? As we are moving forward with our thing. So first thing, right now there are all errors on it because it doesn't recognize where my data is. So first thing is I have to say, okay, where is this data? Scholastic. So under the parameters for retrieve, I have to show it. So go and find under the data, go and find the Scholastic Challenge data set. Okay. Now all of the errors are gone. Now, the very first thing we tried to do here was that, say, for example, I don't want to work with all of these attributes. There were too many of them, right? There are too many of these attributes here. Let's say I don't want to work with all of them. What do I do? So this operator select attributes. If you search it here, you can find it. Select attributes. And then you just drag and drop it here, and then you just link it. So it's already there for now. Now, if you click on that, the parameters change to select attributes. And now here you can say, okay, I don't want to work with all of them. I don't want to select only one, but I want a subset, right? And there are other options as well. You can say by some regular expression, choose like which attributes you want to work with, or I only want to work with attributes that has no missing values. That's an option too. But let's say we want to work on subset of these attributes, and then to select them, you have to click on this select attributes. And then basically initially all of these were on the left side, right? Initially all of them are here. So you have a blank slate here. But then we move them to this side. Okay, now I forgot which attributes we have selected before.
We cancel.
I'm gonna save it, yeah. Okay, there they are. So let's say we have channel, county, bachelor, and so this is completely based on what is the question that you want to answer, or why you think these attributes are important to answer that question, and why you think some of them are not useful to put them aside, and then some of them are just operational. So if you have, say, for example, right here, we have zip code. Well, that's a useful data for just the storage and know which school is within which zip code is located where. But I cannot use zip codes for analysis. I cannot add up two zip codes and come up with a new zip code, right? Or I cannot use zip code to say, for example, as an input to my regression model, right? So that doesn't make any sense. Or if we have titles, I cannot do anything with the titles, right? So some of those are just stays there because they are operational data. They're not the data that you use for analysis. All right, so we can select and bring in the data that we want to bring in. Then there are multiple ways to filter your data and get to the clean data that you want. So one of these is just filter example. Again, that's one of the things you can search from here, filter, and then just choose filter example. You can also filter example range, let's say like from what to what range you want to bring in the data. So let's say we click on that, and you can add filters. Now these filters can be anything. So say, for example, right now we say we want the states to be not missing. We have options. So all of those attributes you've already brought here are now here. Not all the attributes that you have in the data, but the attributes that you have selected them. Okay, now they are listed here. And then next, you have options. So you can say equal to something, not equal to something, is within a certain range, or contains something, or starts with something, So you can just choose what suits your work. And now let's say we don't want to have any missing value for the state. So if there is any missing value on the state, we don't want to see that row, right? We don't want to include that in us. So we can say it's not missing. Now this one, let's say, for the sake of this analysis, we are only interested in public schools. Okay. Now for that matter, then I can choose a school type to be exactly equal public, that class, right? So then if others are there, I don't want to work on them. And then also you can put some logical terms here. Say, for example, the unit price. If I want it to be, then you can choose any sign here, greater than, higher than, equal to, not equal to, and you can provide a set of value. And you can add to this. Let's say if I want to say I want the total units to be, I don't know, greater than, and then you provide some value. It tells you what the maximum is, right? And then you will say, I want all of those that are above 50 for whatever reason, right? So now we just added another condition here for filtering. Once we're done with all of that, we're good, just so okay, and then move on to the next. Now for the missing values, for the missing values, one way to deal with the missing values is just to delete them. That's one way. But you will lose a lot of data when you just delete all the rows with any missing value. So sometimes you don't want to do that. You want to see if you can replace those missing values by some estimation, right? So then the replace missing values option would be a good one. And if you click on it, it gives you the option. And let's say you can choose again a subset if you want to work with some of those. If you want to work with all of them and just apply one rule to all of your attributes, then you just select all. And then you can say, okay, how I want to deal with the missing values. Do I want to put them all zeros? Do I want to replace them with the average of that column? Do I just want to put a new value that I may say, like, sometimes you say, okay, all the missing values, replace them with 9999 or whatever it is. Right. One of the good ways that we usually deal with the missing values is replacing them with the average of the column.
Is there a reason why that you would choose the using the average instead of going with zero or something like that?
Yeah, that's a very good question. The reason that you do it is a lot of times you don't want to lose the entire data, right? So you have to think of a way that what would be the best strategy to not lose the entire row of data, let's say, if only something. So coming back to this data set, let's say right here, well, that's similar. I want something that is numeric. Well, there are a lot of missing values here. I'm just trying to find a good example for it. Okay, so some of these. So you look at, say, for example, this row. Most of the attributes are populated. You have data for them. All these values are populated. So that's actually not a bad row of data. It's actually a good row of data because like most of the attributes are populated. But then you have this unit price missing. Okay. Now, the best strategy would be look at all these other attributes that you have and find something that is very similar to this. Like the one that is above it, it seems like it's very similar to this, right? And just substitute it by the average of those attributes, right? The selling price of those attributes that are very similar to this. Or you can just substitute it by the average of the entire column of the price, right? And the reason is you don't want to lose that row of data because it's valuable. You just have one cell missing, and if you substitute it by the average, you're not really biasing your data towards anything, right? So it saves you the data.
Okay. Thank you, Professor.
Sure. Now, remember I said you don't have to make all the data type changes when you bring in the data. So let's say we haven't done some of those, and now here we can use the operators to change the type. So right now we use the nominal to numeric, but for the type, you have a lot of other options as well. So you say, for example, it was a binomial, but you didn't make the change initially, then you can change the numeric to binomial. Or you can choose numeric to polynomial, or you can choose, like you have different things. They also added this option of guess types. So rapid minor kind of guesses. So that's another option. Then to do this change, like if I click on it, nominal to numeric, then you generally, if you know that like there are a group of them, then you can just select the subset and apply the same rule. If you have only one, then just click single, and let's say you choose the attribute that you want to change it. So right now we have nominal to numeric, product type, right? So for product type, let's see here, what do we have? It's easy actually to look at the statistics. For product type, you see that here you got paperback and hardback, right? Two classes, but because it is text, you basically cannot do any calculation on the text, right? So you need to convert them to codes, right? Now, in order to convert them to codes, that's what we're doing here. It gives you options in terms of how you want to do this coding. Dummy coding is the best strategy for any type of analysis you want to do. And then there's, of course, effect coding, unique integers. Unique integers basically assigns 1 to, say, for example, paperback, and then 2 to the other one, right? So it's just like goes like that. But the challenge with those type of coding is that, say, for example, you put 2 on a hardback, then you are basically giving higher weights, more weight to that class. And that biases your analysis, because you are imposing, so for whatever reason, you just said this is 2 and the other one is 1, right? So you just assigned a higher value on it, and it will biases your analysis. So avoid that. It's best to do the dummy coding. So it creates, right now, because you had 2 classes, then it creates 2 columns out of that, one for paperback, another for hardback. And then whenever, for the paperback column, whenever there is paperback, it puts 1, otherwise it puts 0. So now you only have 1 and 0s in that column. Same thing it does for the other column. So for the hardback. So now whenever it's hardback, it puts 1, otherwise 0, right? So this way you're not introducing any bias yourself into your analysis. And just to see those, if you want, we can just enable some of these so that you see, like, if you want to see what happened so far to your data, we can just run it and see what's going on. So you remember seeing that big data. Now you see that we only see the data that we selected to see, only those attributes. And then now on these, there are no missing values because we got rid of those, the missing values. They're not here anymore. And then we made, you see that for the product type, now you've got 2 attributes, one hardback, one for paperback, and those includes only 0s and 1s, right? You go back to data, you can see that better, right? And then some of the other things we did, what did we do? Say, for example, missing values we just saw. The filter example we had, say, for example, we said unit price less than 100, total units more than 50. So now those as well. So unit price, there. If you can sort it, ascending, descending, and you see that, okay, now the max is 12.9, the min is 3.9. You can actually see that in the statistics as well. So then you know, okay, it is within the range that you selected. Okay, now the data is not deleted, the data is there. It's just that now, because of these operators that you put on it, this becomes the data that you work on. Okay. Now, another good thing you can do here is to generate new attributes. Now I'm gonna link this one. Say, for example, you have to write your own function, of course, here. Let's say we know the unit price, and we know how many units of that product we sold, right? So if I just multiply them, then I can get the sales amount, right? And that's kind of what we're doing here, the sales amount. The calculator here, if you click on it, it gives you the options to write your own formulas. So now you can write any fancy formula that you want to have to generate a new attribute, right? So whatever calculations you could do, just a simple like a logical comparison, something, or an if condition, or a comparison like this, if something is less than or greater than. If you have text information, it also has options for your text information, text transformation, say replace this without concat, or uppercase, lowercase, what have you. And then, of course, there are a lot of other options here. And then you got your attributes here. And then if you want to say, for example, if this is true, then what? Then you can also incorporate those kind of commands here as well. Okay, so then when you're done, so all that goes under your expression. When you're done with that, that's maybe a little coding, a little writing of the formula, but it's like nothing similar to what you do in R or Python. Okay, now that you have, and you can add like, okay, one attribute sales, maybe I need more, so we can add entry and then or remove entry and all that. All right. So now if you run this part only, then you will see that a new attribute generated at the end, and it's called sales, and this is now calculated based on what we wanted, unit price multiplied by the or total order. Now, of course, because we have these two, then you don't want to have both unit price and the orders in the model, right? So you probably need to get rid of those. So again, you can have your another select attribute to just select now the attributes that you, the attributes that you want to work with. So we go even smaller right now because now you want to only work on those that are numeric, right? And only bring those. Now, remember again, I said you can set the role of the attribute in the very beginning, but if you forgot or if you're answering different research questions, and for each question of you another attribute becomes the thing that you want to predict, then you use this set role operator. Make sure you link it. And here now you can say, what is it that I want to predict? Do I want to predict the channel, or do I want to predict, like, I don't know, the sales or something else? That's basically your, like, a big picture of your data cleansing. If I need to, say, for example, remove duplicates, if there are any, then you can use this operator, remove duplicates, and drag and drop it here and work on that. Or say you need to normalize your data, then it gives you the option for normalizing. So you see that everything that you can think, or say, for example, you want to get rid of the outliers, if there are any outliers, then it gives you options in terms of how you want to detect your outliers and get rid of them. One way of looking at the outliers is just go by the rule of the normal curve and say, okay, if it is 3 standard deviation above the mean, I will consider that as an outlier. So you normalize the data, you look at how far away they are from the mean, you remove those high values or very, very low values on the negative side. The approach that RapidMiner takes for detecting outliers is by using the K nearest neighbor method, where it's actually a very cool method. It looks at your data, it puts observations that are very similar to each other, very close in terms of the distance, right, to each other, and into one region. And then it calculates the distance of observations within the region with all the other observations. And if there are observations that are nothing close to anything else, then it will consider those as outliers. Okay, so that's how this outlier detection works. And of course, there are different strategies. Like you can go by distance, you can go by the density of the region, say like something falls like so dispersed, like far away from everything again. Or the regions that are very, 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 like very few observations are in them, then consider the whole region as an outlier. So then this becomes your data preparation, right? When you run this, now your data is clean, is what you wanted to work with, and it's right there. You can have your statistics there by just click on them, and then you can also have your visualization, right? Looking at those charts. So now this data is ready for, first of all, reporting of the descriptives, right? Charts, and now it's ready for your analysis. Then it comes to the part that you gotta decide which model I want to use, and that's something that requires a little prior knowledge of statistics, right? Because RapidMiner gives you all kinds of options. For modeling, you got the predictive modeling modules, the operators here. Your regression models are here. Neural network models are here, neural nets. It gives you for deep learning also, it has an operator. You got your different trees, like right now we just tried a decision tree, but you have your other trees model. It offers a Bayesian technique, naive Bayes model is one of those. Logistic regression for classification, of course. And then discriminant analysis is also another very, very widely used method for classification. And then you got your supervector machines. So, and then on the segmentation, that's basically where you do your clustering models. And there are various operators to, of course, different clustering techniques that we have. And that's the segmentation is for unsupervised learning models in machine learning, where you don't have a label. So this set role is not there. And you just want the data to, you just want to find some patterns in your data, right? You want to identify some hidden patterns in the data that is not known to you. And you want to explore that and see if you can come up, if the clustering can come up with some sort of grouping, then you can look at those two groupings and if there's something out of that. Then you have the associations where you can actually create your association rules. And probably you have heard this example before. There were articles, I don't know when, like many years back. We're talking about when they want to arrange the Walmart shelves they put diapers and beers very close to each other, right? How they derive that conclusion? Well, the association rules will tell you, oh, why or what that happened. And when they did the analysis, they realized that, oh, it seems like dads will come to purchase diapers for their children, and then they see a box of beer next to it, and they immediately wants to buy it. So why not we put them together, right? So that it's right in front of them. Basically, they don't see it initially. They just ran the analysis and see that, yeah, who's there? If dad come to buy diaper in the shopping list, they also bought beer. And then they realized that, okay, why not we just put them together, like very close by. So this kind of finding these type of associations, yeah, can be done with this type of analysis. You got your correlations. Finding the correlation matrix, of course, one of the main things that you always want to do when you're dealing with continuous type data. What is correlated with what? How big is that correlation? Can I use that for finding the association, finding maybe causality? So those are important to see. You got, what have you? Let me close this one so that, yeah. And then there are some options to find the similarity in the data. Well, that is mainly to say, for example, it's not exactly segmentation, it's not exactly the cluster analysis, but it's kind of close. It looks into, okay, what are those data points that are very similar to each other? And the similarity is based on the linkage. You can calculate the linkage between the two observations, say, and there are different formulas for finding that linkage between the observations that you have, and convert your data based on those similarities between the observations. This is not exactly the modeling itself. This is more of a preparation tool for more advanced modeling. And then it, of course, offers the optimization tools for some of the techniques that we use. Say, for example, if you do a decision tree, you see that there are different parameters that you can change, right? And it takes forever. I just saw the Andrew's comment on maybe kids wants to drink too. Yeah, maybe. So what was I saying? Yeah, the optimization of the parameters. So for example, you have your decision tree and you want to change these parameters, but to get to that optimum 3, right? That is gives you the more accurate results, but it's shorter in terms of the how big that 3 is, and you're not losing any of the accuracy of the model. And so this optimization can help you to drive that, right, by changing the parameters. There is this option for time series analysis, and time series analysis, of course, is a huge chapter on its own, where you're looking at only one attribute by looking at, but you're looking at the seasonality, the trends, the cycles that are going on with that one attribute over time, right? In other predictive models, you're basically usually looking at the impact of several attributes on your targets, right? If you want to predict something, you say, yes, I think, say, for example, sales depends on how many orders or what's the customer behavior, what the customer purchased before, and this and that, right? So you look at those attributes and look at how those impact my target variable. But then for the time series analysis, you just look at sales and the changes and the cycles and the ups and downs and all that over time. And that's a very useful analysis way. For like the products that are seasonal in sales, then the time series can really detect. Like a very simple example of that is the sales of ice cream in cold places. Yeah, very simple example, of course. Yeah, the very simple time series model would tell you, yeah, there are warmer months and there are colder months, and then on the colder months you see that the sales drops, but then you see that how much it drops and by what are those rates and all, and then on the hotter months it seems like that is increasing, and so you can kind of predict where your sales are going. There are operators for, so these are basically the models. And then there are operators for scoring, validation, utility, and extensions. So for any machine learning model, basically like the main concept there is, why is it so powerful and why is it different from the traditional estimation methods that we had for many years? And that is because you partition your data in the machine learning. So all the data that you have, you divide it into two parts, assign a part for training and building a model, right? You usually allocate a larger portion of your data for that matter. You train your data with that. And then a smaller portion of your data to test and evaluate the performance of this model, right? And so these validation tools will help you with that. So there are different options: cross-validation, split validation, bootstrapping, and so on and so forth. So this helps you with partitioning your data. Let's say if I do that right here, use a cross-validation. So it, and then you got to say how many folds of the validation I want to have. Let's say 10-fold. And then you decide on the split ratio. So you would say, I want to allocate 70% of the data for training, the other 30% for testing. Okay, so it goes here, 0.7 means that I want 70% for training. And then you choose your sampling because, well, you have to do it based on a sampling strategy. So let's say we go by the stratified sampling, or you could do like simple random sampling. Shuffled will be a simple random sampling. And within this, you see that all these other operators were just one line, one square. But then this one is double. It's just the RapidMiner way to say it's a nested operator. Means that there's something inside of it. So if you double click on it, then it gets you inside of that operator. Now we are inside of the cross validation. And you see there are two windows, one window for training. So 70% of the data is here. And if I go by the same decision tree model here, so just drag and drop it here. So no, we do have these two always, so that we allocate. So the third one, if you basically, that is not though a type of validation, but what we generally do sometimes is that you allocate larger portion of data for training and a smaller for testing, and then you use the model that is already tested and it's good for scoring the other smaller portion of the data to see how good it could predict, right? And sometimes you have, basically the main idea is that you don't have that data now, you want to use this model that is tested to generate those attributes. Say, for example, you wanted to predict sales, right? And based on some attributes, you allocate, say, for example, 60% of this data for training and building that model. then the other 30% you used for testing and evaluating it, right? Now that you are good with your model and you think that this is a good model, then the other 10%, you just take that for scoring. Now you bring in the model that you're good with, that's evaluated, and it looks good, all the indexes fit, and you score the data that you have, the 10%, and then you compare what you actually had and what it is predicted, to have like a second validation, a second round of looking at what's going on in that. Yes, so the confusion matrix is basically the results of that you get right now after this when you're testing your model. Yes. So say, for example, right now we want to do a decision model on the 70% of the data, link it to the model because this is 70%, now we want the model. Then we want to apply, this model that we just created. So apply this model on what? On the other 30%, right? The testing set. So how do I do this? TS to the units, just link it, right? And then you want to look at the performance. Now, there are different operators here that tells you the performance. If I'm doing a classification model right here, a decision tree, I'm doing a classification, then I can use this performance. If I'm having a performance, if a binomial classification I'm doing, then I use this one, because if my target variable has only two classes, maybe yes or no's, or true or falses, or loyal, not loyal customer, like I don't know here how many channels we have, channel 1, channel 2, then I can use the binomial classification. But then if I'm doing a regression model, then I have to use a different, because say how do you look at the performance of a regression model? You look at your R-square, you look at how significant each attributes are, right? So then it requires different indexes for understanding the performance of that model. So depending on what model you're using, the performance will match that. I forgot what we were doing here. We had set rule for channel, and then let's see what channel is. Yeah, we got channel 1, channel 2. Okay. And there are only 3 of channel 1, so we probably do not get a very good model here, but let's try. So because channel has only 2 attributes, then I can use a binomial classification, performance. Yeah, performance for binomial classification, and just link it to the performance. And that way we are setting the model. Why don't you like my, no? I think it should work this way. But now we got the binomial classification, and here you say, what are those things that you want to see? You want to see the accuracy. You want to see, say, for example, the how many true positives, false positives, all that in the confusion matrix you have. You want to see the specificity, sensitivity of your test. So everything that you check mark here, you will see that in the results. Coming back up here, everything I wanted to see in the results, and make sure I link this to the results so that I see them. I see that there is an error here, but I don't know why, but we'll check that. So I'm just making sure everything is linked. All right, Let's see if we can run this. There you go. As I said, because there are only 3 observations on channel 1, so this decision tree is not so fancy. Everything goes to channel 2, of course. We didn't have the data, right? But if you look at the performance, that's the confusion matrix, right? So right here, it tells me that, okay, this is a terrible model, but that's okay. The accuracy is 99%. You want to think that it's a very high accuracy, but it's actually terrible. Why? Because we had everything in channel 2, right? So it just decided that, okay, no matter what, put everything in channel 2, right? You get a 99% accuracy. So that's basically what happened here. I just decided to put everything in channel, predicted. So it gives you true values, channel 1, channel 2. As you saw, we only had 3 for channel 1. And then you got predicted values. So we correctly classify 414 of the channel 2s, but then model just decided to put everything as a channel 2. So then you got 3 of the misclassifications here, right? 3 misclassifications. And so you have a sensitivity of 0 because yes, nothing goes here, but you have a specificity of 100%. Okay, that's a terrible model, not good at all. But that's basically you wanted to see the process. So you just now you saw the process. This is like a very extreme thing that just happened. I don't know if I change something to have more channel 1s, then you'll be able to see a better model. Maybe if I change some of these filterings. The one I added. Let's see how many of these we can get. So that's one thing, working with your data, filters, and I want to see if anything changes, but a better way is probably look into the parameters of that model that you use. Okay, so now you see that because I filtered data so much, so we didn't have a lot of the channel 1, so the model was like so small. But now that we have them, then you see that the tree grows. Actually grows too much, right? But you do have all the description here, all the if thens here. And then if I work with the operators of the decision tree right here, then I can ask it to give me a shorter 3. Let's say change that and say maybe I want to look at the instead of gain ratio. These are the how it calculates what is the most important attribute and puts it on top, right? So there are of course formulas behind each of these. And we run that, then we can get into a different tree. But the thing is, the optimization tools will probably help here as well to kind of. So now you see that I trimmed my tree a little bit, right? So after trimming the tree, now it's more sensible because it's easier to interpret because now it's not that huge anymore. And with just a few ifs, I can nicely get to a conclusion to what goes in channel 1 goes channel 2. Now, if we look at this, the confusion matrix, okay, now I have an accuracy of about 68%. Not perfect, but it's not bad at all. Usually your accuracy of 70% and above considered acceptable accuracy. I have some good classifications, of course, for the channel 2, and then down here for channel 1, and then some misclassifications for each of those. And then you got a sensitivity of 73.6, specificity of 64. Again, I'm not saying this is the best model, but you see that when you change some of the maybe changing your data, or maybe some of the parameters of your model, then you'll be able to generate different models. Okay, so congratulations, we just made our very first machine learning model, RapidMiner. What do you think? I talked too much.
No, it was perfect, Professor. I literally forgot everything about RapidMiner from the last semester. Now that I have it downloaded, I'm gonna start doing the tutorials because I believe that this is gonna make my life way easier with a lot of analytics stuff that I want to do. And also, I know I think for undergraduates classes we don't learn anything about machine learning. And this is an area that I'm really interested about, deep learning, machine learning, and I believe that this could be I can get my feet wet in that area as well.
Yeah, sure.
Do we get to see ROC?
Yeah, sure. So you can get the ROCs here as well, so you can look at the performance once you're on that. If you click on the AUC, then it will generate. So you just click on that, and then when you run it, in the results, just it will also create the ROC curve for you. The red line is the ROC. The RapidMiner has this tendency of showing you a threshold for the ROCs as well, but that's not the ROC curve. The red one is the ROC curve. And you can also, like, if you want to compare different models, it also gives you the option of comparing the ROC. That's usually what you do in your predictive models. Like, you're not only looking at one model, you're looking at various techniques, and then you want to compare them. So actually, that's what I initially had. So if I get rid of that one, this operator comparing ROCs, if you come, that's also another nested. And for this one, this also is a validation technique itself. So you don't have to do a validation prior to this. You can just use that. So it includes that. And with the same cross-validation, so you say how many folds, how many data goes for training, and you choose your modeling and stuff like that. And then it is a nested. So within here, you just put the models that you want to compare. So let's say I have a decision tree, I have a naive Bayes model. You can add as many, say, for example, I want a logistic regression as well. So I can drag and drop that one here and say now feed from the examples. This example just carries forward from one model to the other. So, and then the models goes to the ROC. So MODs goes to the results. Right. So you can add as many as you want. Don't make it too crowded, but you can add to it. And then when I run this, yeah, it takes a little while, but it will generate it. Maybe the data was big for it. And down here it shows where we are. Okay, so now we got, what happened to my, oh, I'm sorry, I didn't link. See, that's what happened. If you don't link it, you don't see it in the output. So that's what happened. We have to go through it again. Yeah, that's what I wanted to show. So it also tells you what operator is taking how long to generate the output. Okay, you done? There you go. So now you got the ROCs, and it's denoted by the color decision tree, the blue one. And it seems like the naive Bayesian logistic model is kind of similarly working, and then it seems like the decision tree is doing a better job in this case for predicting the channels. So yeah, it is actually a very good tool to compare different models, that different predictive models. Any other? Okay.
What's this, Andres? Hold on, let me.
This one is the knowledge discovery book. Oh yeah, let me make sure this is the one that, yeah. This is a good book. I don't know if you've read it. You started working on some of those examples. It has a lot of examples. There are other books as well if you are interested. A simpler one, I don't have it right here. Do I? Maybe not. I have it in the office. Yeah, that. Okay, let me see if I can find that. I can share that with you as well. But that's actually a good book that I put it in my. I use in my class. Some of the cases, not all of them. Though. And more, I believe, it's more usable one.
This one is right.